Hello everybody and welcome to this new webinar on aircraft settings for the EDTO and ETOPS flight planning at Rocket Route. I just want to do some housekeeping. Roman, who is actually sharing the screen. On the right hand side you can see a question mark, and I would really appreciate if we get questions from you. We will do a live Q&A session at the end, and I will try during the session to read all your questions, and if we can show you something in particular, we will be doing that. Further, at the end of our webinar, you will get a link to a survey, and we would really appreciate your feedback, what we can do better, and that is really appreciated. So your presenters for today will be Roman Skripnik. And Roman, maybe you can say a few words about yourself.
Yes, hi everyone, thank you for joining. So I'm one of the business analysts for Rocket Route. I have also a dispatcher background, so nice having you all here. Thanks.
Thank you, Roman. And myself, my name is Ralph Henshin. I'm a business development manager at Rocket Route, and aviation-wise, I'm an ATPL TRE on Airbus fleet. For the agenda for today, we will be going through a general small aircraft setup and then specific into the EDTO ETOPS aircraft settings we have, which most people have not seen or don't understand what to do. We want to highlight there what is needed and how you can do your setup. And at the end, we will have a Q&A session. And without further ado, I'm handing over to Roman, who will share his screen.
Okay, thank you, Rolf. Hi again, everyone. So let me get into the stuff. So first of all, to find the list of your aircraft that are present in your account and to have the further setup of them, you just need to enter our website, then go to more. There you can see the first tab is aircraft, and after clicking on it, you will see the list of all aircraft present in your account. So I will choose this one, Global Express, for the setup. After clicking on it, you will see quite a long list of different tabs with different settings. So I will have a quick overview of every tab. So starting from the top, in the aircraft, you have such fields like aircraft registration, reference, decal number, default flight number, and default type of flight. So aircraft registration can be adjusted if needed. Reference is quite a useful tool when you have several configurations of the same aircraft, and so you can define which one is which. The decal number is the feature that is required for the United States Customs Border Patrol, and default flight number and default type of flight are quite useful when you are flying under the same flight number, so it will be pre-filled automatically on your flight planning stage. So moving to the next tab, this is the type. Here you can see the manufacturer, model, ICAO, aircraft type of your aircraft, and also the aircraft color and markings. Please note that after the aircraft is saved in your account, the manufacturer, model, and aircraft type cannot be changed. So in order to change this, you will need to add either a new aircraft or delete the current aircraft and add the new aircraft. Moving next, the profile. In this tab, you can see that you have the cruise speed, which is the value of the preferred cruise speed for this aircraft. Then the wake turbulence category. There are like light, medium, and heavy. Then the preferred flight level. This value will be used as the default target flight level, which will be sent to our autorouter, and our system will try to find the best suitable route on this flight level. Then you have the SEP climb. This drop down, as you can see, there are several values in it. It will allow to calculate correct SEP climb for your aircraft whenever it's fully loaded or almost fully loaded, and it cannot climb to the required altitude in one go. So minimum flight level and maximum flight level are the settings for the autorouter, so that based on these limits, our system will try to find the best suitable route. And here you can see we have the field of the mean runway lengths. So by defining this value, you will be able to sort alternates based on runway lengths, or also that will provide the notice to airmen for the airports filtered based on this runway length. So moving next to the equipment.
Sorry, Roman.
Here you can see.
If you can go back one step to the runway length.
Sure.
We're going to do a small improvement there where you can actually enter the runway length in meters for those in Europe, and it will be converted into feet. So that is another improvement that we will have there in the next couple of weeks. Thank you, Roman.
Yeah, thanks, Ralph. So moving to the equipment. So here you have the list of equipment that can be present on board. It's navigation, communication equipment. So the first part on the top is the equipment that is listed in the field 10 of the flight plan. Here you can select the transponder mode, and below there is also the performance-based navigation that is listed in the field 18. So all this equipment is selected in this tab and will be further used for the flight plans. Moving next to search and rescue, I think this is self-explanatory. So here you can just set up the survival equipment you have on board. More important is mass and balance. So here you have the full mass and balance configuration of your aircraft, starting with maximum limits, which is max ramp mass, maximum takeoff mass, maximum landing mass, and maximum zero fuel mass. And below you can see the basic empty mass with arm and the all other loading points that are present on board. So moving next, you have the fuel balance table, which is used for calculation of the CG, the center of gravity, for the flight plan. And below there is also the envelope. So these points define the limits of the envelope in which the CG should be calculated. In addition to that, if you use a percentage of Mach for calculating center of gravity, we have the ability to define the Mach and Mach here. So the CG can be calculated using these values. Next, we have standard weights. That's quite a useful feature. So if you operate with a lot of packs on board, so you can define the standard weights for passengers. And we have also the configuration that you can select either summer weights, and they will be used all year long, or you can select summer and winter and define the time during which the one or other should be used. So that's quite a useful feature. And on step 1, you will have the calculator where you can just define the number of passengers, and our system will automatically pick the correct mass for the passengers. Next, we have a big tab is fuel and performance. So as you can see, there is a lot of different fields here. So for the template, we have 2 options, either advanced or basic. What that means that this is the template for fuel flow calculation. Basic template is quite a simple calculation based on the true airspeed and fuel flow per hour. And the advanced calculation is much more sophisticated. It uses the data from provided by the aircraft manufacturer in the POH. and it has different profiles for cruise, descent, climb stages, as well as it uses the calculation for different temperature and mass. So the fuel calculation using the advanced template is far more precise than basic template. Then we have the fuel type, which can be either Jet 1 or F-gas. Then units that can be used for the fuel is either for fuel flow, either gallons per hour, liters per hour, pounds per hour, or kilograms per hour. Then the max fuel capacity of tanks. The default initial fuel, this is the value which will be used for every flight plan you create with this aircraft. And then we have the bunch of settings for the final reserve calculation. There are two options to calculate a final reserve in our system. It's either time-based or constant. So I will start at time-based at this point. So for the time-based calculation, you can define which cruise profile will be used, the time, and also the altitude. So it's either cruise altitude or 1500 feet. And based on these settings, the final reserve will calculate the amount of fuel required. The same settings we have for the VFR flights, this for IFR. The constant setting, it just gives you the possibility to define the amount of fuel which will be used as final reserve. Moving next, we have the contingency fuel calculation. So the contingency fuel is calculated at the percentage value, so either 5% or the 5 minutes using the
sorry, Roman, we just lost your voice there. Roman?
As the reduced, yes.
Sorry, we just lost your voice for some time there when you started with 5%, so I guess some internet issues.
Okay, sure, I will repeat it. So you can set either the percentage value for contingency fuel or certain amount of minutes using certain power profile at cruise or 1500 feet. And also we can just define the amount of fuel as one value. And our system will use the greater of these three settings. Further, if you are allowed to use, if you're certified to use the reduced contingency scenario, we have also the possibility to define this. It is defaulted as 3%. And on step 1, you will have the additional section where you can define the alternate which will be used for this flight, and also some additional details. Then we have the same set of settings for the alternate contingency. This is either our system will choose the bigger of three, is either the 5% or the 5 minutes at cruise with a certain power settings, or the certain amount of fuel. So further, we have the minimum diversion fuel. So it can be defined also approach fuel. That's value that you should preset, and missed approach fuel is also the value which is not calculated automatically. As Rocketfoot is operating globally, there can be different requirements from different CAAs, and also sometimes the data required for this calculation can be missing. So moving further, collapse this one. We have the APG settings. So we have the integration with the APG group. And if you have the account with the APG, so you can use it in Rocketfoot as well. And our system will provide the runway performance calculations in the briefing pack. It's part of the briefing pack. Then we have the EDTO section. I will return it in several minutes to to explain it in more details. The next one is operator. So in operator tab, we have all the details required for the operator contact. Also, you can select either it is a company or a person, and the same set of settings we have for the owner. So these two fields are required when for sometimes for customs, sometimes for landing permit issuing or overflight permit. So it can be requested by the CAA and authorities. And below you have the flight log. So this setting allows you to select a certain kind of flight log template for this specific aircraft. So for example, if you are operating two different aircraft with two different flight log templates, so there's no need to change every time the flight log template in your account settings. You can just define the flight log template specifically for the aircraft, and it will be used automatically by our system. Moving next, we have the briefing pack contents tab. And this tab at the moment contains only one setting. It's adding two additional horizontal wind charts in your briefing pack. So it will calculate two flight levels down and two flight levels up from your maximum cruise flight level for the selected flight. And the last tab is other. So here you have some additional information like MLX address, Euronav SMS number, usual base, then mass and balance sign-off text, and default remarks that will be added as the part of the flight plan with the selected aircraft. So without further ado, I will move back to the EDTO tab and let's dig in here. So in EDTO, we have 4 subtabs. These 4 subtabs, they represent a different set of settings. So for the first one is threshold circle calculation. And here in this tab, you have the following set of settings as minus, that the radius of the circle, then the mass that will be used for the circle calculation, then flight level and power setting. Below you can see that there is also the calculated radius of the circle and also the ability to override this radius. So if you override this radius, all other settings that are above will be ignored, and the value that you entered in the radius override field will be used as the radius of the threshold circle. So, and as well have this checkbox here that use max fuel and maximum takeoff mass. So if you will disable it, these zero fuel mass and fuel fields are enabling, and you can define specific mass and fuel required for you. Moving next, we have the equal time points calculation. So here we have not very much of settings, but if you have these 2 checkboxes enabled, our system will automatically calculate the equal time points based on the actual flight and mass and flight level of the actual flight. You can change it by just disabling it, so you can define the needed flight level on which the equal time point should be calculated, as well as you can define the power profile that should be used for calculating the equal time point. So if it's not the same as in the aircraft, in the flight plan, so you can define it here in the settings. Moving next is the approval area calculation. So this is the graphical representation of the approval area, aka approval circle. So here you have the setting to define the max minus approval. So in the drop downs, we have everything starting from 75 up to 370 minutes. And below, there are several methods of calculating this circle. So as you can see in the drop down. So I will start from the first one, the constant flight level. So this setting will use one flight level, and as you can see, it's max cruise flight level from the flight plan to calculate the radius of the circle. If you want to have this circle calculated on a specific flight level, you just disable this checkbox, and you can see below the cruise flight level to ERA appears, and then you can define the required flight level, as well as the setting with mass. So if you need to change the mass for this setting, you just disable this checkbox, and additional fields appear, similar to the one we have in the threshold circle calculation section. Then moving next, the second one is drift down allowance. So if there is the drift down profile provided by the aircraft manufacturer for your aircraft, our system will use it for the drift down calculation, as well as it defines the level off based on mass and temperature, and you just need to select what cruise profile should be used after level off. So I have selected the single engine max cruise speed. Here you can see that in this drop down you have all possible cruise profiles and as well holding profiles, either single engine or full engine operating. Then, as well as in the previous constant flight level method, you have the ability to adjust aircraft mass, and as well you can adjust the drift down from level, so if it's not correct in the flight plan. In the case where the aircraft manufacturer does not provide a drift down profile for your aircraft, we have a backup solution, which is drift down allowance manual. So this method allows you to define covered distance, used fuel, and time, which is required for the drift down, as well as the drift down to flight level. So our system will calculate automatically from the flight level that you are flying and using in your flight plan. It will use this these settings to calculate the drift down, and after that you have the setting for the level of cruise profile. And the last one is nautical miles override. So basically these settings allow you, at the same as it is in the threshold circle calculation, to override the radius of the circle. So if you have a specific radius of the circle required for your approval array, you can easily find it here, and all the previous settings will be ignored, and this one will be used for the calculation. Moving next, we have scenarios parameters. So here we have all the EDTO ETOPS scenarios settings that are required for the calculation. So the first one is calculate scenarios at EEP and EXP, as it is not mandatory by the regulation to calculate the scenarios at these 2 points. So you can either include it in the EDTO summary or exclude it. Then we have wind correction, so it's a percentage value. And in addition to that, we have ERA holding. So you need to define the altitude of holding and the duration of the holding, and ERA missed approach fuel. So this also is included, so you need to define the fuel value for this. Then moving next to the actual scenarios, the first one is the medical emergency. So you have the option to either include it in the EDTO scenario, or also you can omit it. This second setting is that either use the flight level, the cruise profile, and descent profiles from the actual flight plan, or you can adjust the cruise profile and the flight level, which are your preferred for this type of emergency. So you can see here in the drop down there is a list of all cruise profiles available, and then below you can see there is a flight level input box, so you can define the preferred flight level. The second scenario is one engine inoperative. So here we have a set of settings. So first of all, let me start with the calculation method. It can be either data, so the data that is stored in our system will be used for calculation, or it can be manual. So I will switch to manual, and here you can see that you have this similar set of settings as in the approval area. So you just need to define the drift down settings, and our system will use it as a manual drift down for this calculation. Moving back to data. So as you can see, we have the drift down profile. And if you have more than one, you will be able to select it from the drop-down list. Then you have the cruise profile at level off. Here you also have the list of all cruise profiles available, including single engine, and descent profiles. So this drop-down also includes all descent profiles available for the aircraft, and holding profile. So the values that you have defined in error holding at the top, so it will use these profiles defined in every scenario for calculating the holding fuel. And below you can see that you have a checkbox to apply APU in-flight burn. I will talk about it a bit later. So the next scenario is depressurization with all engines working. So the same approach that you have the data or manual calculation method, but here instead of drift down, you have the emergency descent profile. So you can select here the required profile, but in case the manufacturer does not provide data for the emergency descent profile, you can use the manual scenario, and here you can define the emergency profile using the same set of settings as for the manual drift down calculation. And after that, you just define the cruise profile at level off, descent profile, holding profile, and again, if you need to include APU burn or not. The third the third scenario is depressurization with one engine out. So the same thing here, but for the emergency descent profile, I have used the single engine emergency descent, and here you can see you still have the possibility to choose one of the all possible descent profiles. Again, if manufacturer does not provide the single engine emergency descent, you have the possibility to define it manually, and our system will work totally fine with the data provided in this instance. And after that, you just select the cruise profile at level off, then descent profile to the en route alternate, and then holding profile, and APU burn. At the bottom, you can see you have the APU burn rate per hour. So you have ground APU burn and in-flight APU burn. So at the moment, ground APU burn is not used in the calculation, and we use only in-flight APU burn. So you will need to define what is the burn rate per hour in pounds, or the units that you are using for your aircraft setup. And it will be automatically included in the EDTO summary and the fuel required and fuel flow required for the EDTO. And if you have these settings all set up correctly, I will show you on the example flight that I have prepared. So here you can see this is the flight from Rome to Miami. And you can see the approval area circles as well as threshold circles, and as well the location of the equal time points, equal time points 1 and ETP 2, and the EP, which is here at Lima Echo Sierra Tango, and as well as EXP, which is at Kilo Mike India Alpha. So moving to the EDTO summary. Let me just open it to the full screen. Yeah. So here you can see your flight log with all the important information here in the fuel table. So the contingency, as you can see, final reserve is calculated as 30 minutes based on the settings in my aircraft setup. And moving down to the EDTO summary. Yes, here you have the EDTO summary. As you can see that we calculate the all the scenarios based on the EP, EXP, ETP, sorry, this here, and that we have successfully calculated the threshold circles, approval circles, EP and EXP and ETP, as well as all 4 scenarios. And below you can see the all needed data formatted for the EDTO, and all the divert fuel, total fuel, landing fuel. So everything is calculated based on the settings that you have defined in your account. So on this, I think that's all from my side. Back to you, Rolf.
Thank you, Roman. Thank you for the nice presentation. We have a couple of questions already, but I do encourage people to please hit on the question mark, and if they have any questions, just get back to us. Let me just go through some of the questions. One person is asking, do I need a specific account as I don't see the options in my aircraft? Yes, this is a JetPlan account or a business account. If you don't see those options, get in touch with us at sales@rocketgroup.com and we will fix that for you. Next question, can you set up my aircraft? Yes, for sure. If you send us the POH and you have the correct account, we can set it up for you. The EDTO settings, as we just showed you, it's a very company specific thing. We can help you there, but it's normally done by the company. And can I test this feature? Yes, for sure you can. There are trials available for this, so just get in touch with us at sales@rocketgroup.com and we can set you up there. And that is about it. 1 second. Would it be possible to see a BPJ tab aircraft mass and balance? I can certainly send you one, Sharif. We don't have it in the presentation in a minute, but we could do for sure. We have a couple in the system and we can get back to you after the webinar. And that's all for now. There's some very specific questions, which we will get back to you after the webinar because they're very technical. That's all from my side. I hope everybody has enjoyed this small webinar. We've enlightened a little bit the system, how it works, and please, any problems you have, just get in touch with us at sales@rocketgroup.com. And for those that are not clients yet, please, you can sign up at rocketroute.com for a free trial. And I just thank you all for your time and for attending this webinar. See you next time. Thank you very much, everybody.
Thank you. Bye.